Cool. All right, what we're working on today is probability. So does everyone have a note sheet in front of them? Yeah. Pass them all out during the quiz. All right, so follow along with that as much as you can. There's a couple problems on here that if you guys fill in while we're talking, it'll help you with the activity we're doing later as well as your homework. So the probability of an event is a number, like a fraction or a percentage, usually represented, of the likelihood of that event. None of you guys play the what are the odds game? Like you say you're going to do something and your buddy says what are the odds? All right, well, you know what I'm talking about? Someone know what I'm talking about at least? Kinda? All right. So if I were to say like, I'll jump off that diving board right now and you say what are the odds? And I say 1 in 5. All right, that 1 in 5 is this right here. The 1 is the chance I either jump off the diving board or I don't. I said I was going to, so that's the 1. And the 5 is the possible number of outcomes. All right, so for that situation, you know, things A, B, C, and D can happen. So when we're solving probability problems, that's what we need to keep in mind. So the number of possible outcomes over possible outcomes is going to give you your fraction or your percentage. And these come from the probability of an event. These are examples of events right here. So tossing a coin up and down, what can happen? Heads or tails, right? So if I were to ask you what is the probability that the coin lands on heads, what's the number of favorable outcomes? Just 1, right? It's either heads or it's not, and we want it to be heads, so that's the favorable outcome. And then what's the number of possible outcomes? 2. Good. All right, so rolling a die and it's showing 4. All right, so what's the number of possible or favorable outcomes?
6.
Number of favorable outcomes. So we want a 4. So what are our options?
4.
Just a 4, right? There's only one 4 on there, so it's 1.
50. Good plan.
All right, does that make sense? There's only one 4 on the die, so if we want to roll a 4, that number of favorable outcomes is going to be 1. Because there's only one 4 on there.
I want the other number to be like 7 because it's like 7 numbers on there.
There's 6 numbers on it. But yeah, that's what we're getting to. So number of possible outcomes on the die is 6 because there's 6 numbers on there. All right, now if we were to go to drawing a card from a deck, all right, there's 52 cards in a deck, and I say, what are the odds or what's the probability that we draw 4 out of the deck? So how many 4s are there in a deck of cards? 4, right? So is that our number of favorable outcomes or number of possible outcomes? Favorable, good. And then our number of possible outcomes is going to be?
52.
52, because there's 52 cards. Good. All right, so moving this down. All right, you guys are getting this a little bit. All right, so sitting down right now. Probability of flipping a coin and landing on heads. What did we say that was?
1 out of 2.
Good. Oops.
Good. There you go.
Oh, there we go. All right, so we got that. What is the probability of rolling a die and getting an even number?
Yeah, no.
So
3 out of 6. Yeah,
all right, so 3 out of 6. And then if we are going to write that,
1/2.
good. On top of it. All right, there's a spinner that's split into 4 sections. 1, 2, 3, 4. They're all equal. All right, what's the probability of our spinner landing on a 1 when we spin it?
1.
Good. 1 out of 4. Does that make sense to everyone?
Yeah.
A little bit?
I didn't get the what is the rest of the bell.
Say it again?
Even at 3 odds.
Okay.
Makes sense? Because there's 1, 2, 3, 4, 5, 6 on the die. 2, 4, 6 are even, so it's 3 out of 6.
Oh.
All right, but they're not always going to be like this cut and dry. All right, you guys get that because you understand life and a coin has heads or tails. All right, but so a lot of these problems are going to have dependent and independent variables. All right, so when the outcome of the event does not affect the second event, we're going to say both of the probabilities are independent. All right, the first one does not affect the second one at all. So an example of this is you toss a coin and then you roll a die. Whether the coin lands on heads or tails is not going to affect whether you roll a 4 or 6 on the die, right? Makes sense? All right, another one is, you choose a bracelet from a pile of bracelets, and then you put that one back, and then you put another one. So the number of bracelets doesn't change because you replace it, right? But if we're taking cards out of a deck, for example, all right, you take a queen out of a deck. and then I say, what is the probability on your second choice that you take another queen, for example? We didn't put the first queen back, so the number of cards from step 1 to step 2 are going to be different. That makes sense? We're going to go from 52 cards in the first one to 51 in the second one. All right, so we went through those examples already. All right, so if A and B are independent events, this is what you're going to do to solve them. All right, you're going to do the probability of A. So, for example, flipping a coin, probability of landing on heads is going to be
1.
good. All right, so this one right here, 1. One out of 2. All right, we're going to multiply. For all of these, when you're doing two different events, whether it's independent or dependent, you're going to multiply them. All right, and then so we have what is the probability of flipping a head, 1 out of 2, and then what is the probability of rolling a 7 on a die?
0.
0. Good. So then what's our probability going to be for flipping a head and rolling 7? You got to multiply these, right?
Yeah.
So what's 1/2 times 0? 0. All right, it's never, ever, ever going to happen. All right, which is what we call, I'm sorry, I got to scroll up on this. Sorry. This is, so that's an event with a probability of 0. It absolutely cannot happen because a 7 on a die doesn't exist. A certain event that is certain to happen has a probability of 1. So if I were to ask you, what is the probability that tomorrow is Friday? That probability is going to 1. 100% it's going to be Friday tomorrow, whether you like it or not. Okay? And then all other probabilities are going to be in between 0 and 1. So they're going to be, that's where we get those fractions and those percentages. You'll never have a probability that's over 1, and you'll never have a negative probability. It just doesn't make sense. All right, so moving back down here. Let's say we change this problem, and instead of rolling a 7, we say rolling a 2. All right, so what's the probability that we're going to flip a heads with a coin?
1/2.
1/2, good. All right, 1 option of flipping heads, 2 total options. All right, and then what is the probability of us rolling a 2 on a die? 1 out of 6, right? There's 6 options, there's only 1, 2. All right, so if we were, now with this problem, good, we have to multiply. So it's going to be 1/2 times 1/6, which is going to give us,
6.
think about it, multiplying fractions, right? All right, so the probability of us getting heads, 1/2, times the probability of us getting a 2, 1/6. All right, multiply the top, multiply the bottom.
1/12.
1/12, good. So that is the total probability for that problem. Does that make sense to everyone?
Yeah.
Yeah?
Yeah.
All right, so remember, independent events, they don't affect each other at all. So it's two completely different things, and your probabilities aren't going to change when you go from one to the other. You're just going to multiply them and be good. All right, dependent events are the ones that get a little bit tricky. All right, that's what we talked about earlier with the deck of cards. So the first thing you do is going to affect the second thing you do. All right, so for this problem right here, just what we talked about earlier. Given a deck of cards, what is the probability of choosing the King of Hearts? All right, we'll do that first. So there's 52 cards in a deck, and how many King of Hearts are there?
2,
4.
1.
Wait,
Just King of Hearts.
Oh,
Not
one.
Kings, just King of Hearts.
1.
So 1 out of 52, right?
Yeah.
Oh, yeah,
Times, all right, and the next one is, what is the probability of choosing another card from that suit? So one of the other hearts in the deck. And remember, there's,
0.
hold on,
52.
remember, there's 13 hearts in a deck of cards, 52 total cards. All right, so we took one of the hearts out with the Queen of Hearts.
12 out of 52.
All right, but we didn't put that card back, so how many cards are in the deck?
51.
51, right? Does that make sense to everyone?
No.
It's one that's hard.
It's
All right, think about it. You have a deck of cards in your hand. Think of it this way. You have a deck of cards in your hand. I take one of your cards from you. How many cards do you have left? 51, right? That's the same thing as this problem. You take that King of Hearts out, so you only have 51 left. You're not putting it back. Unless it says you replace the card, then you still have 52. But for this problem, we're not putting that back. So 1 out of 52 for the King of Hearts. There's 12 hearts left in the deck, so what's our second fraction going to be?
2 out of 12 out of
12 out of
51.
Good. All right, and then someone grab your calculator and compute that for us real quick. 12 over some big number, right? Over 221? Did you multiply this? You multiply those? And it was 221? 52 times 51?
Yeah.
All right.
Gotta be bigger than that.
All right. So that, we get 12 over 221, right? And what we want to do with these, as much as we can, is reduce them. Get them reduced as low as you possibly can. I know it's not right. I was waiting for someone to call me out on it. What's 51 times, or 52 times 51? Someone do it on the calculator.
2,600.
There we go.
This, you were
That's what 52 times 51 is. I was just waiting for someone to catch it. All right, so then with that number, all right, reduce it as much as you can. I mean, you guys know how to do that. I'm not going to sit up here and tell you how to reduce fractions. But ideally, we would like to get these probabilities down to 1 over a number. All right, that's not always going to happen perfectly, but try your best to get as close as you can to 1 over a number. All right, now this isn't on your guys' note sheet, so flip this over real quick for me. Flip that sheet over. And make sure you guys write this down, because there's problems on your homework later that involve what we're about to talk about. All right, so ignore what's on the board right now. All right, counting principle. Write that as you're heading up there, please. All right, and this is used for problems where, say, you're guessing like a password on a computer, or you know, you have a 4-letter word. How many possible options are there if you use every letter, or if no letters are repeated, stuff like that. All right, so an example of this, just write this down and you'll understand it. All right, you have a password with 3 letters and 2 numbers. All right, and none of them are repeated.
with what? 3 what?
3 letters.
All right, so no letters and no numbers are repeated at all. All right, we get up to that point?
Alright, yeah.
Good?
Yeah.
All right, so for these problems, all right, there's 5 total spaces we need to fill for this password, right?
Yeah.
So what I like to do is just mark those out right here. 1, 2, 3, 4, 5. All right, we'll say these 3 are letters, and these 2 are numbers. All right, remember, nothing is repeated. So for this first spot right here, how many options do we have? How many letter possibilities do we have to put right here?
3.
Not odds, just what are the options? How many?
3.
3.
There's 3 letters in the alphabet?
Yeah.
Oh.
Just for this spot right here.
27.
Good, 26. I always think it's 27, don't feel bad. I wrote 27 on my notes and had to change it. Alright, so remember, no letters are repeated. So if there's 26 options right here, how many do we have for the second letter in the password?
25.
25, right? Because none of them are repeated. Alright, and then for this one, how many are we going to have?
24.
24, good. Alright, now numbers. It can be 0, 1, all the way through 9. So 10 possibilities. So how many number options do we have right here?
10.
10. And then the second one's going to be 9, right? So you multiply all of those together, Someone do that for me real quick. And those are going to be the number of possibilities for this password. It's going to be like, I want to say it's like 1,404,000.
Oh,
Yeah.
One, you got it right for him.
Yeah, he didn't see study before.
I know, yeah.
Just did it like 10 minutes ago.
Oh.
Alright, so this is just the number of possibilities for this password. Now, if I were to ask you, what is the probability that your friend guesses your password that has 3 letters and 2 numbers and none of them are repeated, what's going to change about this?
Over
1 over this, right? That makes sense to everyone?
Yeah.
Because there's one possible password he can guess. There's not more than one password to get into this kid's computer, right? There's one password, so that's the 1, and then there's still this many possible options. That makes sense? All right, so now I'm going to start calling people up to the board. How do I open this? What's up? Do you want to come up first? All right, so hey, look at these problems. All right, these are not that hard. All right, think about what we just did right here, but with these you can repeat them. All right, so you're not going to have to take anything off these. So we'll do this first one together. All right. 3 entrees, 3 drinks, 4 desserts. All right, you're trying to make 1 plate. All right, and all those things are involved in that. So what are we going to do?
Are you going to just times all those numbers?
Huh?
Don't you just times all those numbers?
Move them.
Yes, I mean.
Oh, multiply all these?
Yeah.
Yeah, it's exactly what you do, because that's going to give us the number of total options.
Let's go into the.
Yeah, what's the first
36.
answer? 36, good. Oh, I got to use the pen. Do I drag it over the top of it?
You might just disappear.
Alright, well that one's right. Alright, so the second one. 2 skirts, 2 blouses, 2 shoes, and 4 purses.
32.
32, that's
2 times 2, 4. 4 times 4, 6. Good. Alright, 32 for this one. None of them are working.
28.
28. Raise your hand.
28, good. Alright.
Yeah, let's raise our hands. You know how class works. Come on.
Alright, we're going to flip a coin and toss a die. Alright, so remember, these aren't the probabilities, these are just the number of options.
12.
Good.
What?
Yeah.
That makes sense, because there's 2 options for a coin, heads or tails, and then there's 6 options for the die. Alright, are there any other good hard ones on here?
No, 18, 17.
Alright, what about this one? Flip 2 coins, toss 1 die.
That's 4.
Good. Alright, just flipping the coin twice, there's 2 options both times, and then the die has 6 sides. Alright, that makes sense? We all good with that?
Yeah.
Alright, I'm going to pass this out. Don't start moving yet, but I'm going to need you guys to get into groups of 2, and then there's going to be 1 group of 3, I believe. Alright, but hold up, don't move yet. Let me explain what we're doing before I have you guys start running around. Alright, so this, I'm going to have you guys do just a little activity to realize that while, you know, the probability of getting a 1 on a die is 1 out of 6, those aren't necessarily set in stone, alright? These are like real life scenarios, so, I mean, you guys have rolled die before. You can get two 2s in a row, alright? And the probability of that happening is not very high, but it's possible. Alright, so in your groups right here, you're going to roll your die 24 times and record the results here, and then just put your final results and all that into this chart, and then I want a fraction and a percentage of what you guys had. Okay, and then I believe the directions on here, you guys have done bar graphs, circle graphs, all that stuff. Alright, so for the dice part, I want you guys to make just a quick bar graph representing the data that your group gets. Alright, it doesn't have to look great, just make sure I can understand what you're trying to say. Alright? And then the second part of it, you're going to flip a coin 20 times, record heads, tails, all the way through. Alright, you're going to mark down right here the totals, again, the fraction and the percentages, and then for that one, I want you to make a circle graph. So it's either going to be cut right down the middle, cut a little bit off to one side, alright? Not super hard. Just make sure those things are legible so I can understand what we're doing, because then later we're going to bring it up as a whole class and record all of our findings and see if, you know, the frequency that the 1, 2, 3, 4 came up matches what it ideally is. Does that make sense? All right, so go ahead, get in your groups of 2 and then one group of 3, and then come up here and get the stuff you need from me.
Come on out, Chris. Come on out, Chris. Come on out.
Be the one. I think you got some other girls. Hold on.
Come up here and grab your guys' stuff when you guys go. Hey, real quick, does everyone understand what we're doing? Alright, make sure you come up here and grab your stuff.
You know something like Caleb. Yeah, turn on that. You want me to grab stuff that he said it's going to be this is the one group of 3. No, it's us.
Alright, does everyone have materials? You guys got the stuff you need? Alright,
Yes, I am. 3. I am.
He said it's